Okay. So I have mentioned this before, but I'm going to mention it again. When you are asked to do this on the AP exam, you very often will be asked to do expected value. To be honest, it's not as common that you'll be asked to do the standard deviation, okay? The expected value, definitely make sure you know how to do that. And part of the reason I keep giving you more and more practice problems on this is just so that it becomes second nature to you. So that if you see it on a test, you don't panic and you're like, I don't know how to do this. Okay, so I entered this first set in my calculator. All right, so let's see. Come on, wake up. There it is. All right, so if I want to get the mean of this, I know I need a multiplication column. So I always call it M for multiplication. Then my formula is going to be the X times the P column. So variable X times variable P. And there's the multiplication. And then you do one variable statistics off of that. So I'm doing that off of my M column now. And that's sigma X, 14.65. That is also called my expected value, 14.65. And that unit would be in the number of credit hours, okay? So that is in the long run, if a student eventually was selected at random from the student body, I would expect them to have about 14.65 credit hours on average, okay? So to get the variance of that, I always call this column VAR to remind myself that this is the column that's going to help me get my variance. And this is where you can use the formulas on the formula page, or if you do this enough, most people learn it. The variance is, in parentheses, the X value, which was in a column that I called X, minus the mean, which we just found was 14.65. Get out of those parentheses and square it, and then multiply times the probability column, which I called P. And then once again, I need that column all added up. So menu, statistics, one variable calculations. I now need the variance column. And sigma X 4.2275. 4.2275. That would be in credit hours squared, which is why we then square root it and we get 2.056. And now we're back to hours. Everyone good with that? Okay. Now, one of the things that the reason I want to go through this also is I want to refresh some things on the calculator. Okay. What I'm going to do now is this just says that I want every credit hour is costing $90. So someone who takes 12 credit hours, 12 times 90 gives me 1,080, 13 times 90, okay? So what I would do is I'm not gonna type in a whole new column. What I'm gonna do is I'm just gonna make a new column and I'll call this T for tuition. And I'm gonna set that up as a formula of, I want what was in my X column, variable X, and I want to multiply that by 90. And I don't need to retype that whole column because now I can go through the same procedure, but instead of using the X's, I'm now going to be using the T's for tuition, okay? So you can then, it'll save yourself a little bit of typing if you learn how to set up those formulas, okay? If you did this one correctly, you should have come up with an expected value of, and I'm going to call this one E of T for tuition. You should have come up with 1318.50, I think. And this is tuition, so this is now in dollars. Your variance, I had the variance came out to be fairly large again. I have 34,242.8, and that would now actually be in dollars squared. When you take the square root of it, you should be back into dollars, and it should be 185.05. Were you able to get that? Now, keep in mind on my Inspire, I would have been going through all those same steps again. So the next couple of columns would have kept getting filled up with my, my sigma columns and things like that. But the bottom line is on this one, it says, suppose every person, not only do they sign up for their credit hours, not only do they pay $90 per credit hour, everyone has to pay a flat rate of $50 just for registration fees. So now what happens is I want to take these tuition amounts and everyone has to get a $50 added onto it. Okay. So again, don't retype the whole column of information. Just set up a formula. I would call this one C for cost. My formula is going to be, I want the old tuition cost. So variable T for tuition. And then they have to pay an extra $50 in registration. There they are. And now I can go through all the same steps, but now don't use the X column, don't use the T column, use the C column. Okay, save yourself some time on some of this. All right, so the expected amount for total cost, I should have come out to be $1368.50. The variance, 34,242.8. That would be in dollars squared. And then square rooting brings me back to $185.05. All right, just because I don't want my 84s to feel left out, I'm going to go through a couple of these ideas on the 84 as well. Remember, 84s, you can overwrite your columns. So when you first create that multiplication column, where you do L1 times L2, what did I type in wrong there? L1 times L2, there we go. Okay, so when you first set up that multiplication column, then you do statistics, you do your one variable statistics off of L3. There's your sigma x of 1465. Okay, and when you're done with that, so you go back to stat and edit. You don't need that column anymore. So you can now override and say, all right, now I'm going to turn this into my variance column. And you could say what I need is everything that's in L1 minus that 1465, parentheses squared, times the probability in L2. And then you can do your one variable statistics once again on L3. Okay, so there's the 4.2275. What you can do now, when you go back and you want to do the next set of problems, when you go to edit, okay, I am going to back up now. And what I'm going to do is I'm going to change my L1, where on an Inspire, they keep creating new columns for their original X, and then their T, and then their C. You could come back and say, well, I'm done with this. I need these numbers now multiplied by 90. So I'm going to go up to the tippy top and say, I want you to take everything that's already in L1, and I want you to multiply by 90. So there's that column. And now I can come back and start the process over, again, back in L3. Okay, and then when I'm ready for the next part, and I could say, okay, I need everything that's in L1. I need you to add 50. There are those new numbers. And then you can go back and do all your extra work in L3. Okay, you need to get some practice with the calculator so you know how to be efficient with it also. Okay, you have a calculator for every test you take with me. You have the calculator on the AP exam, but you want to be efficient with it so you're not wasting time trying to figure out how to use your calculator. All right, so while I've been up here yapping, did you happen to look at these numbers? Did you notice anything about these numbers? If you look at it from step to step to step, did you notice anything? Anything stand out to you at all? Nothing looks interesting or weird or strange? Yes. All right. To me, that's the first, and that one definitely, that stuck out to me as I was writing it down for you. Okay? That's actually a rule that you need to know. Is when you're dealing with random variables, each one of these is a random variable. X was a random variable because, again, I could randomly select a student and they might have this many credit hours. T is a random variable because I could randomly select a student and they might pay this much in tuition. C is a random variable because I could randomly pick a student and they might pay this much in cost. What you need to know is that anytime you move from one random variable to another, in this case, we moved from T to C. The only difference from T to C was that C was defined as T added to 50. You should know that if a random variable only changes by addition or subtraction, because that's really the same as adding a negative number, if you change a random variable simply by adding or subtracting a number, it will not impact your variance or your standard deviation. It's a rule that you should know. If a random variable changes only by addition or subtraction, it will not change the variance or the standard deviation. Okay, so while we're looking at how T became C, what do you notice about the expected value between them? Okay, so when I moved from T to C by adding $50, that's all it did to that total. This right here, the expected value of C was the expected value of T increased by 50. That's a rule that you should know. Anytime you add or subtract a number to a random variable, the expected value is going to change by that exact amount, and your standard deviation and variance aren't going to change at all. Okay, so Michaela's got us started between the T and the C. Let's back up and talk about how X became T. What mathematical operation did we do to go from X to T? All right, so we did this. T was defined as 90 times X. T was equal to 90 times X. So if we look at this down here and we say, well, this was just $50 more down here. What might you think happened from here to here then? Let's check it out. If we went back to that 1465 and we multiplied by 90, 1318.50, that's exactly what happened. The expected value of T was the expected value of X multiplied by the 90. So the multiplication and division, by the way, it follows the same rule. If you're going from one random variable to another, if you multiply by something, the expected value is going to change by that exact same scale factor. Did the standard deviation do the same thing? Did the standard deviation go up by a factor of 90? Can you estimate what's 2 plus a little more times 90? What's 2 times 90? And we have 185.05. That's the little extra. You could confirm this, 2.056 times 90, 185.04. Okay, it was off because that was rounded a little bit. But this is true. This is true right here. The standard deviation for T was equal to standard deviation for X, also multiplied by 90. Was it also true for the variance? It's 90 squared, which makes sense because you haven't square rooted yet. If you took that 4.2275 and you multiply by 90 squared, that's where that comes from. So the variance of t was the variance of x multiplied by 90 squared. The biggest thing that you need to take away from this is anytime you are changing one random variable into another, whether you're going from x to t to c, multiplication will impact the mean, it will impact the variance, and it will impact the standard deviation. Addition will impact only the mean. It will not impact your variance or your standard deviation. And that's actually what's on the next page here. Effects of transformations on the mean and standard deviation. All right, y and x are random variables. So if you start with random variable x and it's turning into y, if you're starting with x and it's turning into y by multiplication, well, then your mean is going to be impacted by that multiplication. Your standard deviation is also going to be impacted by that multiplication. But if you are changing with addition, the addition will only change for the mean. It will not change your variance and standard deviation. Okay? If you are dealing with data and random variables, the effects are the same. These results apply to both discrete and continuous random variables. Okay, so here's an example. In a large introductory college stat course, X is given as raw scores on a test. All right, so if you had the probability distribution, X would be the scores, and you might have the probability of X. But you know, we don't even have all that. They didn't give that to us. They already helped us out. They said that the mean of X was 17.2, and the standard deviation for X was 3.8. So assuming it's points. Now the professor decides, oh, those scores came in kind of low. I need to help them out a little bit. So the professor says, I am going to multiply their scores by 4, and I'm going to add 10. So we're going to take their scores and multiply by 4 and add 10, and we're going to create a new random variable for y. You don't need all the numbers. You can use this. The rule says if you now want to do the expected value for y, multiplication and addition will both have an impact. You are going to have to take the expected value for x and multiply it by 4, and then also add the 10. So if I take that 17.2 and I multiply by 4, I get 68.8. And then I add 10 and I get 78.8. That's now my new mean. Without knowing all the student scores, without knowing all of this, I got it. And then it says find the standard deviation. Now here's where people make their mistake. The standard deviation is not impacted by the addition. So all you're going to do is take the standard deviation for x and multiply it by 4. So 3.8 times 4 gives me 15.2. Addition and subtraction have no impact. So then it says, what is the probability that a randomly selected student has a scaled test score of at least 90? All right, well, it says we have a normal distribution. All right, so if it has a normal distribution, I could draw a picture of this. And now we're talking about the scaled score. So this is now variable y. So I would know that the mean for y has to be dead center. So that would be the 78.8. And there you could mark your standard deviations, and you could add your 15.2s and subtract your 15.2s. I'm not even going to do that. I'm just going to set up my problem. What's the probability that the score is at least 90? So greater than or equal to 90. I'm going to convert that to a z-score because it's a normal distribution. All right, do we have the z-score formula memorized yet since chapter 2? A z-score is always the value you're trying to convert minus the mean divided by the standard deviation, which is 15.2. Now, just looking at that setup and looking at your picture, 90 would be somewhere over here. And I'm looking for greater than. So when I'm all done, I know I'm looking for a positive z-score, about 1 or so. And I'm looking for a final answer that's less than 50%. So I pull out my calculator and I do 90 minus 78.8. That gives me 11.2. And I divide by 15.2. So I get a z-score of about 0.74. And then you either use your chart or your normal CDF. I will pull up my Inspire here and I'll do menu, probability, distributions, normal CDF. Lower bound is going to be that 0.74. Upper bound is going to be a very large positive number. Just tab through the 0 and the 1. 4 decimal places, I would call that 0.2. Actually, what I want to do is I want to see what that looks like longer. I would call that 0.2296. Do you guys understand why I wanted to extend that decimal? You see what happened here when the Inspire automatically rounded it for you? It said 0.5 because it took that 9 and it rounded the 4 to a 5. But if I hadn't looked at that, I might have rounded that 5 and sent the 6 up to a 7. But that was only a 5 because it had already gotten rounded. So when I want to look for 4 decimal places, I look at that 5th one, and that 4 was not large enough to round the 6. So 0.2296 should be the best answer. Now, on the AP exam, would they accept 0.2297 if you actually wrote that? Most likely. Now, what we're going to talk about tomorrow and Monday, this is called transforming a random variable. We took X and we transformed it by multiplying and adding. Remember we did graphical transformations in Algebra 2? Okay, that's what we did here. We just took something, we transformed it. What we're going to do tomorrow and Monday is we are going to combine random variables themselves. Okay, so I'm going to take 2 random variables like X and Y, and we're going to add those together. Okay, so that's going to be a little bit different. You definitely have enough information to work on your part 1 here. And hopefully this video works. And our friends at home, they caught up.